Welcome students. Now we are entering to our third problem in our chapter 1, electric charges and fields. Okay. So this problem is not belongs to our Coulomb's law. This is another type of problem. So first problem and second problem there is some difference, all based on Coulomb's law concept. We did in our previous videos we have seen. In this problem, third problem, it is also based on chapter 1, but it is completely based on electric field. So this problem we are going to discuss about the concept of electric field charges, the Coulomb's law. That Coulomb's law we did very well, so that topic is over. Now we are entering to the concept of electric field. So this is another variation of the problem. Let's see how it goes. Okay, first anything when you're going to start the problem, we need to read the problem very much clearly. This is very important thing which everyone have to listen. Okay, first what the problem they given. A particle of mass 10 to power minus 3 kg. 10 to power minus 3 is nothing but called milli. You know very well, this is milligram, millikilogram, and charge of 5 microcoulomb. So micro, this is mu. I think you know the value of mu into 10 to the power of minus 6, right? Is thrown at a speed of 20 meter per second. A particle of mass 10 to the power minus 3 gram and charge which have 5 microcoulomb is thrown at a speed of 20 meter per second. So 20 meter per second means they are just throwing a velocity of 20 meter per second a particle of mass. That particle it can be any particle. Okay, that speed they given. So against a uniform electric field, they given electric field also here, the 2 into 10 to the power 5 Newton per coulomb. This is a unit of electric field. Okay, then what they are telling to find here? How much distance will it travel before coming to rest momentarily? Very important thing you have to listen here, students. This is very important thing. Very super question, very interesting question. You have to listen very clearly, understand the topic. How much distance? They are asking distance here as yes. Okay. How we travel before coming to rest? Before coming to rest, there is important thing. You have to underline the word from here to here. This is the very important thing. All the students are stucking into the problems because they are not reading the question very clearly. If you read the question very clearly, understand the data and the formula, you will do the problem very easily. There is nothing doubt in it. So before coming to rest momentarily means they are telling that there will be a particle which is going to be impact with any one substance. It will become rest. Then initial velocity C also u equal to 0. And momentarily means it should be stopped. Okay, so this is the things they given. So first we have to write the data, then only we will be able to know which formula is suitable for here. Okay, first writing the data. Okay, first what they given here as mass. M is equal to 10 to the power of minus 3 kilogram. So what I am telling here, they given mass value is perfect. They written as kilogram, so no issue. Next they given us here charge Q. What they given? 5 microcoulomb. So microcoulomb means we have to convert what 5 into 10 to the power of minus 6 coulomb. So charge, mass is all there in the data. I have written very clearly, right? Thrown at is speed, that is velocity. V they given us 20 meter per second, ms inverse 1. This is the velocity they given. Uniform electric field. Electric field is E. What is E they given us? 2 into 10 to the power of 5 Newton per coulomb. 2 into 10 to the power of 5 Newton per coulomb. So electric field they written. Okay. How much distance? How much distance? So to find they are asking here as distance. Distance nothing but here as S. Or we can keep R. That is not a problem. Distance yes. Will it travel before coming to rest? Before coming to rest. That is the important thing you have to understand the question. The particle have to be before coming to rest. It should be momentarily. Then what will happen at initial? What will happen? The velocity is always equal to 0. You know very well. So they are asking the display distance means which formula is suitable when the particle is moving, the particle is at motion. Generally it should go for kinematics, right? We studied in chapter 11, that is standard 11, sorry. In this standard 11, we studied in chapter 2 as well as the equation of motion. We know three famous equations: V equal to U plus AT, S equal to UT plus half AT square, V square equal to U square plus 2AS. So among these three equations, only we can able to find out the displacement, distance. So what is the formula? I am going to use here as V square equal to U square plus 2AS. So this is the equation of motion I am going to use here. You can ask one question that, sir, how you are using this formula? So read the question: the particle of the substance which is moving, and they are telling to find the distance of the particle which is before coming to rest. They are given very clearly. So when it is motion, in the sense we should go for always equation of motion. From this I am choosing here as this equation because I need to find out here as displacement S. So because of that I am using this equation, V square equal to U square plus 2AS. Okay, so this is the formula. Next one we are going to do as solution. So next we are going to do here as what? Solution. Okay, so data and to find and formula, everything is written. So we are going to find out displacement here. Okay, so first, before going to find out the displacement directly, we don't know the acceleration. We need to find out acceleration, right? Because initially we know that the velocity is 0, so we have to find out here as acceleration. So how will we find out acceleration? F is equal to ma, but here is come as minus. Why it is come as minus? In the sense it is acting as rest the position which is momentarily. So we have to take here as opposite direction. So we keeping as minus. So we should find out a equal to minus of f by m. First we have to find acceleration. So here we take means we have mass, but we don't know force. So force common formula we studied in the electric field. The force is exerted on the electric field. What is the formula? Can you remember? Yes, F is equal to QE. F is equal to QE. From this we can find out force. From this we can able to substitute the acceleration, from which we can go for what? Velocity. So velocity is here as we can momentarily means we can take U or V. That is not a problem. So at the initial position, so we can consider V also is equal to 0. So V equal to 0. Okay, wow. Because it is rest now before coming to rest, so I am making as V equal to 0. Final velocity. So now we can equate the equation. F is equal to what? The given charge Q? 5 into 10 to the power of minus 6 into what is the electric field? 2 into 10 to the power of 5. What answer we will get? 5 2s are 10. So minus 6 plus 5 we will get minus 1 Newton. So 10 into 10 to the power of minus 1 Newton. How we can write this equation as F is equal to 10 Newton. There is nothing but 1 Newton. Minus 1 means it will become as 1.0. Force we found out as 1 Newton. So we found out force here as 1 Newton. Okay. Next we are going to substitute as acceleration. A equal to minus of F by m. So minus you will get as F as 1. M, what is mass we count out here? 10 to the power of minus 3. So what is the answer we get for acceleration? Minus 1 into, it will goes upward, it becomes 10 to the power of 3. Unit of acceleration is ms inverse 2. This is SI unit of acceleration. Because force is here as 1 ma. So as per formula minus, I am putting minus 1. Mass is, we know that 10 to the power minus 3, it goes upward, it becomes 10 to the power plus 3. The value is minus 1, you are putting like this. This is acceleration. Force found out, acceleration find out, then we can go for equation. V square equal to U square plus 2AS. Okay, so we know that very well that before coming to rest, so the final velocity is always equal to 0. Then we can make as 0 equal to U square plus 2AS. 0 equal to what is initial velocity U here? What the velocity they given here? 20. So 20 the whole square plus 2 into what is acceleration here? Minus of 1 into 10 to the power of 3 into S. Okay, so 20 square equal to 400 minus 2 into 10 to the power of 3 second. Okay, now we are going to equate this equation. So we are making this one 400 equal to 2 into 10 to the power of 3 second. Okay, now from this we can going to find out S. So S equal to 400 divided by 2 into 10 to the power of 3. So if we cancel, we will get the answer as 200. The plus 3 will go to upward, it becomes as minus 3. So 200 into 10 to the power of minus 3 meter. This is the answer. So if we made 10 to the power minus 3, if we keep here as, it will become as meter. Now the answer will become as 0.2 meter. Both answers are same. Cancelling here, 2 times 2 ones are 2 200s are into 10 to the power plus 3, minus 3 will become as plus 3. So plus 3 will become as minus 3. So I am making here 200 10 to the power minus 3 meter. If I keep this 3 value as decimal of 10 to the power minus 3, it becomes 0.2. So distance unit is meter. So answer is S equal to 0.2 meter. Or we can write as 200 into 10 to the power of minus 3 meter. Both answers are right. So this is the answer. Okay, this is the answer. So please go through the concept once again and you will understand very easily. So this is the problem or solution of the third one. Remaining things we will see on our next video. Thank you, students.